Have you ever wondered what drives the creation of some of the most daring and enigmatic weapons in history? Enter the Yokosuka MXY-7, known poetically as the Ohka or Cherry Blossom, a manned missile that embodies a unique blend of innovation and desperation. Crafted by ingenious Japanese engineers, this weapon's beautiful name belies its deadly intent. Allied forces, recognizing its peril, dubbed it the Baka Bomb or Idiot Bomb. Our focus today is on the operational Model 11, a version that not only took flight but also carried out harrowing missions. Join us as we delve into the intricate design and perilous journeys of the Ohka, uncovering the dark allure and tragic bravery that marked its place in the annals of aerial warfare. Before we dive into today's fascinating topic, please take a moment to subscribe to our channel for more captivating content. Now, let's explore the world of the Ohka. Fuselage. The Ohka's fuselage had a sleek and elongated shape, measuring 19 feet 11 inches in length and nearly 2 feet in diameter. Inside, it had a strong aluminum frame supported by longitudinal members called longerons. These longerons gave the fuselage its structural integrity. The exterior of the fuselage was covered with aluminum sheets, carefully attached to create a tough yet lightweight skin. However, the nose section was reserved for the Warhead, a heavy payload that added weight to the front of the aircraft. The wings, with a span of 16 feet 10 inches, were also made of aluminum, but they had balsa wood skinning to keep them light. At the rear of the Ohka, there was a twin-tail configuration, which not only provided stability and control during flight but also acted as a counterbalance to the weight of the Warhead in the front. This design ensured that the Ohka remained balanced and maneuverable despite its powerful payload. For Warhead. Located at the forefront of the Ohka was its powerful Warhead, nestled within the extended nose section. Designed for maximum armor-piercing effectiveness, the Warhead was encased in steel, adding to its formidable weight of 2,646 pounds. Within this weighty casing resided 1,141 pounds of explosive material, ready to unleash devastation upon impact. The Warhead's construction included 5 fuses, 4 positioned at its base and 1 housed within the nose itself. Prior to deployment, each fuse required careful arming by the pilot, a meticulous process essential for ensuring the Ohka's operational readiness. This critical step demanded precision and attention to detail, as any oversight could compromise the effectiveness of the Warhead upon reaching its intended target. Therefore, the pilot's thorough preparation and execution of the arming procedure were paramount to the success of the Ohka's mission. Engine. The Ohka was powered by 3 Type 4 Mark I Model 20 rocket engines, which were incredible feats of engineering. These engines used solid rocket propulsion, a technology that burns solid fuel to create high-pressure, high-temperature gases. This process generates thrust, propelling the missile forward at high speeds. The engines were made up of a unique mixture of chemicals, including nitrocellulose, nitroglycerin, mononitronaphthalene, ethyl centralite, and various volatile substances. This specific combination of ingredients allowed the engines to burn efficiently and produce a remarkable 588 pound-feet of thrust. The ignition process was a critical part of the engine's operation. It started with a small igniter located at the back of the engine, which would light up and start the combustion process. Once ignited, the solid propellant burned rapidly, creating a powerful and sustained thrust that launched the Ohka into the air. The entire process was a carefully orchestrated event, showcasing both power and precision. The engineers who designed these engines had to ensure that every component worked perfectly together, from the initial ignition to the final thrust. This level of detail and craftsmanship made the Ohka's engines not only powerful but also reliable. Their ability to generate such high thrust from solid propellant was a significant technological achievement at the time. The engine's performance was a testament to the advanced engineering and innovative thinking that went into creating the Ohka, reflecting a deep understanding of rocket propulsion principles and materials science. Cockpit. Inside the cockpit of the Ohka, the pilot took control of the aircraft, relying on a variety of instruments and controls to guide the mission. These instruments included switches for arming the Warhead fuses, selecting the rocket motors, and communicating with the carrying aircraft. The cockpit was equipped with several crucial flight data indicators to help the pilot navigate and control the aircraft effectively. Altimeters displayed the aircraft's altitude, allowing the pilot to know how high they were flying. Airspeed indicators showed how fast the aircraft was moving through the air, which was vital for maintaining proper speed and control. The orientation of the aircraft was conveyed through gyroscopic turn and slip indicators, which helped the pilot understand the aircraft's position and movement in the air. In addition to these instruments, inclinometers provided valuable information about the vertical angle of the aircraft's flight, letting the pilot know whether the aircraft was climbing, descending, or flying level. Ensuring that all the electrical systems were working correctly was also a crucial part of the pilot's responsibilities. For this, the cockpit had circuit test switches, which the pilot could use to check the operation of various electrical components and systems. All these instruments and controls were essential for the pilot to perform their mission accurately and safely. The combination of these tools allowed the pilot to maintain control, navigate effectively, and communicate with the supporting aircraft, ensuring the success of the mission. The detailed and precise design of the cockpit's instruments and controls was a testament to the importance of pilot awareness and control in the operation of the Ohka controls. The pilot's expertise with the joystick and rudder controls was essential for navigating the Ohka with precision. The joystick was the primary tool for adjusting the ailerons and elevators, which controlled the aircraft's roll and pitch. Moving the joystick left or right adjusted the roll, allowing the aircraft to tilt and turn, while moving it forward or backward controlled the pitch, raising or lowering the nose. These adjustments were crucial for maintaining control and navigating the Ohka through the air. Additionally, the rudder control, managed by a pivotal bar, was vital for adjusting yaw, allowing the aircraft to change direction left or right without rolling. This ensured stable and precise flight, keeping the Ohka on a steady course. Each movement of the joystick and rudder bar had to be executed with precision, as every input directly influenced the missile's trajectory. The pilot's skill in manipulating these controls was critical for the mission's success, requiring a deep understanding of the aircraft's behavior and quick, accurate adjustments. The combination of the joystick for roll and pitch and the rudder bar for yaw allowed for complex aerial maneuvers, highlighting the importance of pilot expertise in effectively operating the Ohka. Starting process. The Ohka's journey started beneath the wings of a Mitsubishi G4M2E Betty bomber, which acted as its flying launch pad. This bomber carried the Ohka into the sky, and when the time was right, it released the missile, setting it on a dangerous path toward its target. The range the Ohka could travel depended greatly on the altitude at which it was released, making the release height a critical part of planning each mission. As the Ohka glided through the air after being dropped, the pilot had to carefully monitor the flight and prepare for the next crucial step. At the right moment, the pilot would ignite the engines, activating the powerful rockets that would propel the Ohka forward at high speed. This ignition was the turning point of the mission, transforming the gliding missile into a fast-moving projectile aimed at its target. The pilot's role was crucial at this stage, as they needed to ensure the missile stayed on course and maintained its trajectory. With the engines roaring and the Ohka accelerating rapidly, the pilot guided the missile with unwavering determination towards its final destination, driven by the mission's critical objectives. This sequence of events, from release to ignition, highlighted the intricate coordination and precise timing required to operate the Ohka effectively, showcasing the blend of advanced technology and human skill necessary for such high-stakes missions. Flight. As the Ohka hurtled towards its target, a potent fusion of speed and precision, its mission entered a critical phase. With engines ablaze, the missile surged forward, its trajectory guided by the pilot's deft hand. Each rocket burn, a testament to engineering prowess, propelled the Ohka towards its fateful rendezvous with destiny, a collision course with enemy vessels, poised to unleash devastation upon impact. The Yokosuka MXY-7 Ohka, a testament to human ingenuity and resolve, left an indelible mark on the annals of aerial warfare. Its daring design and unwavering commitment to duty embodied the spirit of innovation and sacrifice. Though its operational tenure was brief, its legacy endures, a poignant reminder of the human cost of conflict and the resilience of the human spirit in the face of adversity. If you like this video, please like, subscribe, and press the bell icon for more videos. Take care, bye.